Hello, YouTubers. This is one of the videos where we start talking about a standard change. For those of you who are not familiar with, the standard or the engineering standard, it's basically a set of patterns and rules that are put together to constitute an engineering standard that can allow engineers to build end-to-end enterprise level platforms that are reliable, configurable, extensible without having to worry about, following a particular pattern or knowing what the end result may be, especially for people who haven't had the chance to build end-to-end platforms in the past. This particular video, every once in a while, the standard itself, as I always say, the engineering standard is not complete and it's not perfect and never will be because the engineering industry grows super fast and there's always changes that happen in our industry that requires us to kind of revisit existing, assumptions we had and, revise existing, ideas that we thought of when we started building the standard as we grow and as we learn, as the language is learning, is growing, and the frameworks that we're using, growing. There are so many different factors, that basically surround making a particular decision about, taking on a particular engineering standard and adapting it to help teams basically build proper software. Okay, so what am I talking about here exactly? The title of this video says exceptions and validations. Exceptions and validations. This is a change. These things happen all the time, but sometimes some of them are bigger than others, right? Sometimes I will come out and say, hey guys, the engineering standard which we use to build our software, we're going to follow a new pattern, and here's what this pattern looks like, and this is why we're doing what we're doing. Let me just jump ahead in here and just give people a little bit of, insight about, what our engineering standard looks like, for those who are not familiar with the with our engineering standard and what it really means. And then I'm going to tell you about some very interesting things that will follow that particular idea, and hopefully you'll find this video useful for you. Okay, so here's my screen. If you see in here, one of my most popular repositories really is that the standard, and the standard is basically where you go and say, I want to be able to build reliable enterprise level software, and it has a set of rules. Things like, every broker should own their own configurations. Brokers are not supposed to handle exceptions. They should delegate that upstream to foundation services. But if you notice in the foundation services area, you'll notice here that, I went ahead and said, oh, you're supposed to write some validation rules. And then if you scroll down a little bit, you'll see some examples in terms of unit testing. You'll see me saying something to the effect of, here we go, should throw validation exception on register student when ID is invalid. Right? This is literally what we're going to be talking about today. The idea of validating particular fields, in a student object, and when we hit the endpoint or we try to consume the service with an ID that's invalid or a name that's invalid, it basically captures that error and basically throws the exception, says something is wrong with this model. To see this in real life, you can look at one of my favorite projects, really my favorite open source projects, OSSS, the open source schooling system. Here is an API that I'm going to run for you, and I'm going to show you this, in real time. I'm going to show you how we're going to really transform an entire existing open source project into something that, completely different, completely new, standardized, newer way of handling exceptions. Okay, so this is my API, and I'm going to go up in here into Postman. And I'm just going to go ahead and try to post a student. Now watch this. I'm posting a student with an ID, right? I'm even going to take the ID. I'm going to go up in here and say, you know what, throw that ID away. So I'm basically posting really invalid object. See, you'll notice that it says invalid student ID parameter name is this parameter value. So it's basically saying, the student that you just posted has an invalid parameter name parameter value, right? What's the problem with this? Now every time I go and add, okay, I'm looking at this error message and it's telling me, go ahead, you need to fix your ID. So I fix the ID and I hit again. Oh, I have a problem now that the created by cannot be just an empty value. Oh, okay, then let me go and create, an ID for the created by in here, just some random ID for now. And if I go and hit that guy, it will go and say, this is created by good. What was the oh, a comma in here. Okay, so now if I hit like this, it'll say, oh, invalid ID, the updated by. See, what's the problem here? Every time I try to hit the API is coming back with a different message, a different validation message. And that's really terrible. That's terrible basically because, you know, from an experience standpoint, if someone is sitting behind a UI component and they're, you know, hitting the button, every time something fails, it comes back to them, you know, and says, oh, you need to fix this. Why don't you just give me a list of all the problems that I have so I can fix it once? It's even better API economy from in terms of, you know, being able to communicate with the API and have the client basically fix the issues in that system, you know, instead of having to go back and forth between them and the client. And this issue has been bothering me for a while. Believe it or not, it took me like an entire year to just think about, you know, a proper way to evolve the engineering standard to bring it into a concept, a native concept or a local concept. There's already libraries, a lot of libraries out there, things like Fluent validations, right? There's libraries out there like Fluent validation. And Fluent validation basically gives you that kind of power to go and say, well, you know, I want to create a customer validator and then abstract validator and need to pass the model. And then the model needs to, you know, is kind of tied up. The setup and the experience of it, it was just not convenient for me. It's not pretty. You know, it needs to be pretty and simple and easy to understand, but also at the same time, I don't want to be tied to a particular model or particular implementation. You know, it looks like it's fluent, it looks like it's attractive, and a lot of people actually use the fluent validations. There's even native implementations, you know, that come outside of the box with components for Blazor and all that. But it's just not convenient for me. It just doesn't look right, right? And it takes away, one of the biggest problems is that your validation is your core business logic. Your job is to try to abstract away any external dependencies on that business logic as much as you can. So you want to clear out your business logic from any external dependencies as much as you can. This is like rule number one in the standard. Your core business logic is nothing but local models, models that you've created by hand, functions that you created by hand, so it can withstand time. You know, when there's any changes in the technology or any changes in the industry itself, you can still pick up your foundation services with your processing service and coordination services and just hook them up to whatever new thing that's out there, because it's just pure C#. There is no magic there. So you try to stay away from pulling in libraries and pulling in frameworks that, you know, that are supported by a third party or even a first party provider. Okay, so we need something better than this. We need something that, you know, can show us, you know, how we can basically catch all the issues that are in a particular object and be able to communicate these issues, you know, through the controller and handle them on the client. I'm going to show you the entire story today, from the moment you're having validation issue in your service to the moment how your controller is translating that to the moment how your UI or your client or consumer is going to receive that and process it. Okay. Let's start from the beginning. Let's open up let's bring our Blackboard in here and let's just start from scratch. So when we're building something, you have your foundation service in here. This is my foundation service. And that foundation service is talking to some external broker, right? So this broker is wrapping up, say, storage. Doesn't matter what the case is. But it also is talking to a controller. So this controller here is receiving a request from the outside world, and the request is coming in. Let's say this is your student model, and let's call it a model since we're staying generic here. So this is your model, and your model is coming in through the controller, and the controller is relaying that information to your foundation. Your foundation service is executing validations, right? So these are your validations. We want to be able to collect all these validations and send the response back to your controller, right? And your controller will pick up that new exception that you created with with all the validation errors and communicate that to the client, the consumer that posted that student in first place. What would that look like? Let me show you something, a glimpse of what we're going to be implementing here today together. So you just understand, if you look at your native implementations, if you go and use something like data annotations, just so you understand, I find data annotations, especially the ones that say, oh, these fields are required and all that kind of stuff, to be very, very dangerous, because testing these things is cumbersome and your model should stay very anemic without any annotations, so you move it around and move your business logic around without having to look in 3, 4, 5 different places where you're collecting how this model being validated. But that's a story for another day. I'm just going to use this as an example, so I just show you, how you're supposed to communicate error. ASP.NET Core, actually this has been around since even MVC days, right? If you put an annotation like required like this on top of your ID or whatever field you have, if you hit the API endpoint with this ID not available, it will communicate standardized problem details. And standardized problem details basically is the standard way for RESTful APIs to be able to communicate errors. So if I take all these properties and hit like this, here we go. So this is student. Did I put that guy in the right place? This ID required. That's right. So let me go back here. Post. Did I restart my? Let me restart my API here real quick. Okay, that's my API, and then I'm gonna go up in here. I'm gonna hit that guy. Ah, that's weird. Okay, so let's see if I. This is required by what? I want required. I think it's JSON required. My apologies. I think the new thing is it's JSON required. There you go. So if you do JSON, it used to be required back in the day, but now it's JSON required. So let's run this real quick. And now if I hit my API like this, here you go. And now if I go and hit my API, it will communicate a meaningful error. See that meaningful error in here? It basically says, here's your errors. Here's the type of that error. So it's a link to the standard of HTTP API calls. What does this error mean? This 400. And then a title and maybe a trace ID and a status. Right? That's the proper way you're supposed to kind of throw an exception in a RESTful API communication. If you go into the RFC standard in here, you're going to find a lot of search, and I'll tell you why I have a lot of these RFC links. If you go to RFC links like this, it will tell you, oh, there's this error and these errors. Actually, not even this one. Hold on. Let me find the right one for you. RFC HTTP. I think it's this one. Yeah, you'll find many of these, but I really want to find you the RFC status codes. There you go. And then I think it's this one. Yeah, there you go. See, this is the standard, right? This is how you go and say, okay, what does 200 mean? What does 201 mean? These codes are really, really important, because when you go to these codes, it'll explain to you what this error as a standard, as an API standard, actually means, right? So when you go to this, it'll basically tell you, well, a bad request means this, payment required means this, forbidden means this. That's really what this link is referring to. Like if you go back to the API response here, if I copy this link here and I paste it up in here, it'll take me pretty much to the same page. And that's how you're supposed to be expressing a problem. Now, someone might say, where did you come up with this problem detail? If you go and type in RFC problem detail, like this, it'll talk to you exactly about what problem details are and how you're supposed to communicate them. There's a whole bunch. I'm going to give you all these links in the description of this video so you just understand, where I'm coming from and understand how you're supposed to communicate errors through your API. So it'll tell you you're supposed to have a type and a title, maybe some detail, give me the instance, balance, accounts, some details about the issues that are happening in your system. And the ASP.NET team, they took that and they created their own native class library, sorry, class model that they call problem detail. They even have another one called validation problem detail, which we're going to talk about. This is going to be a little bit of a long session, so bear with me because this is really, really important. Okay, so you have this and you have this problem detail, and that's the standardized way that you're supposed to be communicating through an API. Now, we're throwing exceptions. We have three problems now. We're throwing exceptions per attribute, per model, which is really terrible. We're supposed to be collecting all the problems and then sending them over. That's one. And then the second problem that we have is that we need a way that can catch an exception and extract all the errors from it somehow to communicate the errors to the controller, and for the controller to pick up these errors and be able to spit it out as a list of all the issues that are happening, as a dictionary, basically key value kind of pair. And then the third problem is a client that can read that problem detail and actually know how to translate it. Okay, so going back to the map here, so we need in every place here, I'm going to put here, the issues that we have. So, because that's really what we're going to do today. In here, I want to collect errors, all the errors. Collecting all the errors, collect errors like this. And then in here, serialize errors into problem details. And then in here, deserialize errors, right, into exceptions. So I want to throw an exception here, and the exception will have the details, and then the details will turn into a problem detail, and then the problem detail will get deserialized and turned back into an exception that the client that's reading this exception can process it and work with it. I'm going to show you all of this today. Okay, let's start with this guy here. Let's start with going and saying, this is my OSSS project in here. This is the portal, this is the API. And let's start just with a simple one, which is basically the actual project itself. Just for the purpose of this demo, let me increase the font here for people that are on their phones so they can just see. I'm going to go for 175 here. Here we go. Everything's super large. Here we go. Let me minimize this. Okay. Okay. Let's see if I can make this work here. Okay. So this is the code. This is OSSS portal. I need the API, so that's my API right here. And then I'm gonna talk a little bit. Let me revert the changes that I had for the model in here. So this is my model here. I'm gonna really revert everything. And then we're gonna start talking about some libraries and some tools that we've created that will actually help you move forward, fixing this problem. This will help you kind of supercharge your existing ASP.NET APIs to the next level. So you're not just barfing out an exception anymore, and your client doesn't know what to do with it, and it's always 500 internal server error. It's a lot more detailed than that when you're trying to handle exception and work with errors. Okay. So let's start from the top. The first thing I want to do, I want to have a specific type of exceptions, right, that will be able to handle these kind of errors, right? So if you look at any exception, let's just go into the validation area here in the student service. This is my student service. And in my student service, you'll see here that sometimes I throw an exception, right? So I go and say, well, if the student is null, then null student exception. If the ID is valid, see, with every error, I'm throwing a special exception with it, right? With the parameter name and parameter value. And then this parameter name and parameter value come out as just flat line like this. That's really meaningless. It doesn't really mean anything. But there's something interesting about these exceptions. If you go like this and say var x equal new exception like this, and if you go like this and say x, which is the exception dot data, you'll find something really interesting. exceptions allow you to add a key value pair, that allows you to add errors. Like you can go up in here and say, well, ID, cannot be empty, like this. And then you can add as many as you want, and all of this can be carried over with the one exception that carries all the invalid student exception issue. Okay, so that's the first finding. That's the first thing I noticed, is that your exception can actually contain, or carry a baggage of errors with it. So instead of throwing the one exception with the message, we can use that one exception to do a lot more than just that. Okay, so we got this part. Now we're going to run into another problem. Sometimes some elements, they could have multiple errors. Like this ID could have multiple errors, and these errors might happen in two different places. Like for instance, you could be validating that created by is not supposed to be null, but also created by is supposed to be the same as updated by, if you're allowing that kind of anemic model through the system. Could be anything. It could be, you could say name can't be null, and it can be less than 3 characters. Right? So these are two validation errors that belong to the same attribute, which basically means, because this data guy is technically a dictionary, you can't just go and say add ID and add ID again, or add name and add name again, because dictionaries by definition, by design, they only can allow unique keys into them. So you can't just go and say, well, every time I find a problem, I'm just going to go and add this. We need some form of absorption, right? An absurd mechanism that allows me to go and say, well, I want to pass in actually a list of errors to this guy, and every time I have a new error, I'm going to append a new error to that list. Okay, so that's not something that you can get outside of the box with the normal exception, right? What would we do to make something like this work? Let me show you. Let's just say in here, I'm gonna go up in here and say public void, or private, doesn't matter really. Private void, absert to exception. And here is a key, and here's a value. I'm just gonna show you how complicated it is to do something like that today, and how simplified we can make it. Okay, so something like this, right? Okay, let's say you have an exception. So it says var exception, or let's say you have an existing exception in the system, right? In order for you to make something like this happens, you would need to define, outside of this realm, you need to define a private exception kind of model, like this. Here's my exception right here, and then start appending to that. Now look how painful it is to be able to append to that exception. You'd want to go and say, well, if exception.data contains, you're checking the key. If that key, it's one of two things. Either the key exists, so you want to append the existing data, or the key doesn't exist, then it's easy. If the key doesn't exist, you can just go and say add, and here is my new key, and I'm going to create a new list from scratch, list of errors, so therefore it's going to be a string, a list of strings. I'm just going to add the value in there. This one is easy. The crazy one is when you go and say, well, the key does already exist, but I want to add to that existing list. In this case, you want to go and do something like this, exception.data of that key, right, as a list of strings. If that list is not null, then go ahead and add a new value. So see how crazy this is? So you're basically going and saying, get whatever value is inside that key and map it into a string, a list of strings. So map that data. This is a very advanced topic, by the way. This is not your usual, let me walk you from scratch. This is an existing engineering standard that's running really in production systems today, and I'm actually kind of blowing it all up and starting over. So bear with me here. This is a very advanced topic. So I'm basically going here and saying, let's just go through this again. I'm basically going and saying, here's the value. Since this key exists, let me find the value inside that key. So I'm accessing it by index. Dictionaries will allow you to access a value or by the key as an index in its stringified format, and then map that to a list, and then go and add that value if that list is not null. All right. Someone might say, well, the list will never be null according to this definition. Yeah, but you still have to protect yourself. So I'm putting in the Elvis annotation, Elvis Presley annotation there, or like some people like to call it, the safe navigation. It's a feature that was, I think, in Perl or Ruby, and then it's now in C#. Okay, that's how you would go about doing something like this. Now, this is inconvenient. You can't just have engineers remember that off the top of their heads, right? So I thought to myself, you know what? I know how to publish .NET libraries. I know how to publish NuGet packages. So I'm just going to go up in here and install a very simple library that's called Xeption with the X. So Xeption, like this. Xeption 1.3. This library basically, I can't believe there's already 135 downloads. That's crazy. But you know, I just published this, you know, like yesterday. But the thing about Xeption Library is that it allow me to kind of not have to deal with that nonsense, and it will keep my code simple and clean. But also at the same time, it's not invasive. It doesn't intrude, you know, into my my core business logic, right? It's just a simple library that gives me a better exception level than what I already have in the native .NET framework exceptions. Okay, so it's this piece. How do we use this exception library? I'm gonna go up in here and create a new, just for the purpose of this demo. I'm gonna create a special class. That would be your normal, you know, invalid student exception. Here, let's create this guy, and I'm gonna go ahead and say invalid student here, invalid student exception, just like this. Okay, and this invalid this is the new .NET 6. They take away the namespaces. Don't really like that approach, but anyway. So you have this invalid student exception, which is just an exception class, right? And inside that student exception, I think that class is already in there. Okay. I'm gonna change this to invalid student, the native one. I'm gonna change it to invalid student input, so we can just move forward with the new one here. It's this guy. I'm just gonna rename the world. Just gotta change a few things. Okay, there you go. So this existing file in the system is called invalid student input and exception. I'm just gonna go to this one and call it invalid student exception. That's gonna be the one that I'm gonna be using to basically communicate all the messages that I want to do. Okay, and this guy is gonna inherit from exception, which is the library that I just added. And I'm gonna tell you what this crazy library does. It does something really simple for you, but it's gonna help us a lot simplify our code and make our code a lot cleaner, you know, than it can be, than it would be if we did this by hand. And then in this invalid student exception, I'm just gonna take a message. That's all. Because I generated this error, there's no really stack here to worry about. I'm just gonna pass in the message to this guy, and that's all for now. Okay, let me add in a copyright notice here. Here you go. And I'm gonna create this, I'm gonna put this in a branch so people would understand, you know, that this is just something that, you know, I'm doing on the side so people could see how things are working. Okay, so I created an invalid student exception, and that exception is inheriting from this new library called exception. What that basically means is that I can use this exception class to handle this whole if-else statement that I made earlier. So I don't have to worry about this absorption of data. Every time there is an error, I can just append to that error, and that's all. Now here comes the second problem with this. Let's go back into our validation logic. Our validation logic itself will fundamentally change. Because if I go in here and say, well, create an exception in here, like this, invalid student exception like this. If I go and do this, right, what's going to happen is that I don't know if, like, if you go into your case, you know, your switch case, you can't just go up in here and say invalid student exception dot, you know, look at this new library, add absert data list. See, this will do the trick for me. But the problem is, like, okay, I'm gonna go with the key here and say this is student dot ID, and then maybe the message here is, you know, student ID cannot be null. The problem with this in here is that your switch case pattern that you're using to kind of collect these errors and collect these problems is not going to work anymore, because it's expecting you to break. It's expecting you to go like this and say break and move on. Only in this case here, it'll let you move forward with your work. But if you break, that means you won't be able to collect the rest of these errors. Even if they're invalid, you won't be able to collect the rest of these errors. So a new pattern needs to happen. A new pattern that tells me when I'm going to pass in a list of rules to you, and you validate all these rules. Let me visualize this for you so you understand. You know, I'm going to pass in a list of rules. Let's take a new page here. So I need, like, from a visualization standpoint, I need an encapsulator that takes in a bunch of rules. So let's say these are my rules. These are all my validations. So this is the rule. I'm running the rule against the particular model. So your input here is the model that's coming in. Here's my model that's coming in like this. And this model coming in, and you're validating all these rules. So this is rule 1 and rule 2 and rule 3 and rule n. So I'm validating all of these rules against my model. And for each and every one of these rules, first of all, the rules are not dependent on each other. So there is in no way, shape, or form one rule has impact on the other, right? What that basically means that I'm going to have in here a collector, validations collector, and it will check for each one of these rules. So for every one of these rules individually, it'll go and say, you know, validate and collect, validate and collect. Does this model match this rule? Yes, it does. Oh, no, it doesn't. No, it's not going to work. You know, and so on and so forth, like this. And then at the very end, this validation guy will check and see, right, throw or not. So this exception, this validation collector, which is basically the exception, the exception library, it will go and say, well, at the very end of this journey here, if any of these rules, let's say this rule passed, but these two failed, these two rules failed, that means throw or not. Throw if I have any issues with my rules in here, then immediately we need to throw. This is basically the model that I'm trying to build here. I need to pass in a model or a property of a model, and then for each property I'm going to apply a rule, right? And the rules the results of these rules will be collected in here. And then at the very end, if any of these rules have failed, or all of them, some of them, or all, go ahead and throw the exception. That's the theory. That's the idea behind what I'm trying to accomplish. But how do you draw this in a way that's beautiful? It has to be really, really beautiful. What I noticed here is that there are two things. There's a parameter in the model that you're experimenting against or validating against in terms of validation. So you're basically running the rule of is null or empty against first name, middle name, last name. So it's the same rule, but you're running it against multiple parameters in your model. But at the same time, so I need a parameter. I need to know what the parameter is. I need to know what the rule is. So we need a parameter. My code needs to allow me to pass in a parameter. And I need a rule or a condition. And I also need rule message, when there is our validation message. So when the rule fails, I want to know what the validation message is. On top of this, I want to know the rule or the condition result. So this is condition or rule, and then I want the condition result. These four things need to happen in an iterative way. So this guy here is replaceable, and then we run against the same three pieces. But one of these pieces, or two of these pieces, light up when this guy here says I'm invalid, then this guy says I'm available. Okay, so we need something to pass in all these four parameters to kind of encapsulate, you know, the validations that are happening. It needs to be dynamic, it needs to be simple, it needs to be easy. An engineer could remember it off the top of their heads. How the heck do we do that? How do we go about doing that? Let's write our little function together. I'm just going to fix this guy real quick. I don't think we need even to pass a message in here. What I really need to do is to go and say, you know, base invalid student. Please try again. Something to that effect. This is invalid student. Check the errors and try again. Invalid student. Check the errors and try again. Okay. Let's be nice. Let's say please check the errors and try again. How about that? Please check the errors and try again. Okay, so I don't need a message in here because the message is already baked in. The details of this message is what this exception is going to kind of collect for me. Okay. Let's go and build a nice function for ourselves here. Control MO will collapse all of that stuff. Great. And then I'm going to start from the top here so I can kind of move away all the stuff that you and I don't care about at the moment. Okay. So I need a private void method because that method is not going to really return anything. It's just collecting errors and throwing an exception, right? Okay. This method, let's call it validate for now. And this method is going to take a tuple. Bear with me here. It's going to take a tuple of a dynamic model, right? And this dynamic model, I can call it condition or rule. Sorry, rule. A rule has a condition, and if the condition is satisfied. And in addition to that, it'll just take a parameter. That's okay. I want to know the parameter, and I want to know the rule. And the rule has a condition and a message. If the condition is satisfied, it will spit out the message. Right? But I want this validate function to take infinite number of these. I want to be able to pass a bunch of rules to this function in here. So there's this cool thing in C# that's called param. And params will say I can allow you to add as many number of input parameters to this. So if this is an array like this, I would call this validations. So these are your validation rules. Is this correct as a C# statement? Absolutely 100,000%. This is a correct statement. So I'm passing in a dynamic object, and this object here will contain a condition and a message. And the condition is Boolean, and the message is a string. And also, it will contain the parameter. Let me make this uppercase because this is a tuple. A parameter that will tell me which parameter does this rule apply to. So this parameter is going to play the role of the key to the dictionary that we're trying to create. Okay, so let's go up in here and say, well, for each, right, for each, and these are coming in, right, I'm going to go up in here and say, well, for each rule, dynamic rule, and a parameter in these validations, because this is where I'm doing these iterations, so I'm iterating on these validations, right? If rule.condition is true. So I'm going to put a condition in this dynamic model that's coming in. If it's true, then go ahead and call that exception. Well, now we need that exception. So I'm going to go ahead in here and says invalid student exception equal new invalid student exception like this. Okay. So invalid student exception dot assert data lists. This here saves me this whole nonsense that I was doing earlier with the if else statement and, you know, cast to a string and, you know, pull it back from the string. Because if you put that logic in here, you have to test it because it becomes immediately yours, right? We don't have to do that. Okay, so the key will be the parameter, of course, and then the value of this will be the rule.message. Just as simple as that. Okay, think about this just for a second. You know, we're passing infinite number. Of course, this is a very advanced topic, so I'm assuming you have that prerequisite of knowing advanced C# concepts. I'm using like 3 or 4 at the same time here. I'm going and saying, oh, use a tuple. And inside the tuple, use a dynamic object, which is a parameter list of validations. But the code is still, in general, pretty and readable. Pretty and readable. Okay. So this exception library allowed me here to basically go and pick up that student exception model that I created. And it allowed me to go and assert this data list values right away without any issues. One more thing. If this guy has errors in it, if at least one of these conditions, remember like in our model here I said if at least one of them has failed of these conditions, we need to throw an exception. If and only if there are errors. I already took care of that one for you as well. I'm going to go up in here and say invalid student exception, throw if contains errors. That's it. Okay, throw if contains errors. That basically means it will only throw that exception if and only if the data attribute on that exception has elements in it. All right, so this is one part. And this is the toughest part in this whole conversation, this whole video. If you understand this piece, everything else is easy peasy. There's no problem there with any of that. Okay. Now let's create some rules, right? Let's create some rules. How are we going to write our rules? We used to write our rules like this. We used to go and say is invalid, input string is null or empty or white space, right? The problem with that is that it does tell the user that the student is invalid and the parameter name is name, but it doesn't tell the user why it's invalid, right? Maybe if I want to put a rule that says the name is not supposed to be more than 10 characters, right? And they put 10 characters. The existing standard model will just go and say invalid, but it won't tell you why. That's very inconvenient and very, very terrible, you know, moving onwards. So let's create a rule. So it's private. So our rule is dynamic. So that means it returns a dynamic object. Okay, we get that part. And then I'm going to go here and say validate. And I'm going to take string as text. Watch what I'm going to do here. I'm returning a new dynamic object. Watch this. And in this new dynamic object, I'm creating what? Remember how when we said the rule will have a condition and a message? Yeah, I'm going to do exactly that. The condition here will be string is null or white space. So that's the text. And if that condition is satisfied, then I want the message that comes out to say, text cannot be null, empty, or white space. That's the validation message that I want to put in there. That's how we're going to be able to write rules. Let's do another one. Another one would be something like validate for a GUID value. Here, ID. right? And I'm going to go up in here and say if ID equal GUID.empty. Here's another validation rule. You can put whatever you want in there, and it's very easy to understand. You know, you can go here and say ID cannot be empty. Something to that effect, right? Maybe you have a rule in there that says, well, two values are supposed to be the same. Let's try this. I can go up in here and say private dynamic, right, is not same. And here's first ID. See how flexible the rules are going to be and how easy it is gonna be to write these rules. And then there is second ID. And maybe since I'm passing the parameter, let's pass in second ID name, because I'm not passing this as part of the other rules. So what I'm going to do here, I'm going to go up in here and say, well, fat arrow, new. Here's my model. Here's my condition. Let me knock these input parameters down by 1. And I'm going to go up in here and say, well, the condition here is that first ID does not equal second ID. If these IDs are not the same, then we have a problem. Okay, what's the message? ID is not the same as, see, and now I can go up in here and do some interpolation. And I can go here and say second ID name, like this. So what am I doing? I'm basically going and saying, I can pass in these rules whatever I want because it's a dynamic object. Okay, so I created a bunch of rules as an example, and I created this validate method. It's complaining here because it needs to be static. Okay, because it doesn't really require an instance or any of that stuff. Okay. Okay, so we have all that kind of stuff. All of these can be static actually because they don't really require any an instance of the class. Now the last interesting part. How are we going to write these rules? Remember how we were writing these rules by going and saying validate, you know, student on create, go add each and every one of these rules. Now it's going to be much simpler than that. I can go up in here and say private void validate student on add just for now. And I'm going to pass in the student model in here like this. You still get to throw the null exception. Nothing stops you from doing that. But this is a different story. Now I get to go and say validate like this. And for each and every one of these validate, I can pass in a new rule. So look, how is this going to look like? I'm going to go here and say rule and then valid and then say I need is valid. Sorry, is valid. Let me use is valid instead of validate because that's now overloaded term. Yeah, so is valid, and I'm gonna go and say student.id. Okay, so that's the first one, and then the second piece that I'm throwing in here is the parameter. So it's name of student.id. Okay, I can add as many rules as I want. If I do control D like this, I can add as many rules as I want because that's the power of this little param model that allows me to add as many as I want on the fly through the method itself. See how I'm passing my rules? See how I reshaped how my rules look like so I can control them in a way that's still readable, but at the same time flexible to communicate more than just the error that's happening in the system. All right, so what's the next thing? Let's add in let's exercise all the things that we just did. So you have created by is also supposed to be not supposed to be valid, and then there's updated by, and I'm gonna take these properties, and here's a student. Why am I not using the model itself? Here's the student model, right? So I have all that, and then I want to add in more validation. So there's text in there, right? So let's say, do I have name? You got first name, you got middle name. Come on. middle name, and then you got last name. I'm going to make everything mandatory so people would understand last name. Here we go. Okay, so that's last name. And then I'm going to experiment with other kinds of rules. The rules that compares other objects to other objects, something like this. I'm going to go up in here and say, well, here's a new rule for you. And the rule here is not same. I don't know what happened to Visual Studio. It's just super slow. It's trying to figure out what the heck I'm doing, basically. I'm confusing Visual Studio, basically. Actually, before I do that, let me fix these. So this is first name, middle name, last name. And here's your student model. Okay, it's not same. What says not same? Created by and updated by is supposed to be the same names. Okay, I'm going to go up in here and say first ID, second ID. That's student dot updated by, like this. And then there is the second ID name, which is name of student dot updated by. So this is the ID that is supposed to be the same. And then what else do I have in here? I need to pass in the parameter piece, which is name of created by. So that's student dot created by, like this. So this is going to spit out an error. It says created by is supposed to be the same as updated by. See how we changed how our rules look like? So this how, if you look from a high level perspective, our rules used to look like something like this, right? And now they look something like this. A very simplified model from a high level perspective. This is how I look at the code. I look at it from a high level perspective and see if it looks pretty. It has to look pretty. And we're gonna intentionally, so this is the part. We reshaped, we completely changed how we, as an engineering standard, which basically is gonna change across all my projects, how we collect these errors. Okay, so this is one part. Now, the second part is to be able to handle that exception. So I'm gonna use this function here in my student service. So instead of validate student on create, I'm going to say validate student on add. And in my try catch, and if you're not familiar with this pattern, please go and in my videos and understand the try catch pattern. You know, these patterns keep piling up and we keep kind of making our code look even better and better. And instead of student input exception, I'm just going to say invalid student exception. This is just for this demo. So I'm changing from invalid student input, which is the one that didn't inherit from exception, the native one, the one that was outside of the box, that was existing in this repository. And now I am putting in this invalid student exception, which is the guy that is carrying all the good stuff, all the errors. What else is left? What's left is that this error is going to be wrapped up in a validation exception that's going to be propagated all the way up to the controller. And I want this guy specifically, right? So if you go up to the controller here, to the student controller, actually, let me show you what this looks like first. If I go and hit that API first, I'm going to hit the API with a student model, and it's just going to spit out this student is invalid. Like, it won't know what to do with it, right? Here. Just to show you the difference between the two. So what's my student model look like? That's my student model here. It's empty. It's really bad. It has a lot of errors. If I go and hit post a student model like this, look what's going to come back from my controller. Invalid student. Please check the errors and try again. This is not how you're supposed to respond in an API. Let me take away the camera here so people can see. This is not a standardized way. This is not a problem detail. This is really not okay, right? This used to be something that we used to do in the past, but not anymore. We're changing the standard. Well then, if I have the exception, let's first ask this question. Does the exception have the information that I need? For starters, so if I go into the student controller in here, and I try to catch this student validation exception, which is this guy right here. I'm going to put a breakpoint in here so we can just figure out, is this student validation has the right information or not? Does it? I don't know. Let's find out. So here's, I'm clicking send, and then here's the exception. I'm going to open that exception up, and then I'm going to open the data piece, and I'm going to expand in here. Sorry, on the inner exception of this guy, because it's in the inner exception. That's right, the inner exception, and then the data piece, and lo and behold, you have 6 errors, and each one of them has a key value pair, and the value is a list. See that? That's the beauty of the exception library. It basically collects that information for you. You see what I'm saying? So that's basically the issue that we have here. Okay. So I have the right exception. I just don't know how to serialize it into a problem detail. I don't know how to pick up that error that I just collected from a validation standpoint and push that through with a problem detail. I got you there. So I just very recently added a new change to the RESTFulSense library. And if you're not familiar with this library has over 27,000 downloads. It's basically something that we instantiate our student controller with, and it has all the missing code, all the missing codes in the, see, it has everything. It has, like, based on the standard, it has, like, your native controller base doesn't have all these errors. You'll see insufficient storage, you'll see length required, you'll see locked. Locked is not native, it doesn't come outside of the box, right? There's variant also negotiates. There's all kinds of errors. If you look at the library itself, just so you understand what this RESTFulSense library is, it basically streamlines your API communication. This is why it's so popular, because it basically makes your API communication so much easier. If you look at the documentation here, I collected every single HTTP error that you could possibly get, and I'm turning it into meaningful exception and meaningful methods that you can work with. But here comes the fun part. Look at the, there's a branch that I just created. And this branch, my friend, is, here it is. Yeah, problem details. It's a huge branch. And what this branch contains, and I already published the library, I just need to merge this in. You'll see a lot of tests in this branch, about 92 commits. It's a huge branch, and 52 files. And what these files are, the changes that I made in here, is that I collected every single URL that will point to an HTTP error, and I converted the exception with its data into a problem detail. I'll show you exactly how crazy this is. Let me merge this real quick on the fly, while we're at it, since I already published the library. I don't have automated processes on the build or anything. I just build it locally and shoot it out there. So, okay, so there's this thing. Let me go and upgrade my RESTFulSense. This is a breaking change. Just heads up for the people that actually are using this library, are interested in it. This is actually, it has backwards compatibility, so you're gonna be fine. Don't worry about it. I already took care of the people that are already using this library in the old standard way. No worries there. I got you. There's this version 2.0. And this version has the power to basically, instead of us doing all this nonsense with the exception and, oh, give me the inner exception and do all that nonsense, it will take your exception, your validation exception, and turn it into a problem detail. And I'm going to show you in a second how beautiful this is. Here we go. Let's give it a second there. I'm really sorry in this video if I'm throwing a lot of stuff at you. I'm just trying to get as much details as possible out there, so you know what I'm talking about. Feel free to, reach out through the video and ask questions, but just stay with me. We're still getting, we're 50% there. Like we already talked about, from a map standpoint, we already talked about this piece here. All these pieces here, we're already done here. Now we're talking about this area here, the serialization. There's still another area here that I need to talk to you about. So we're still not done with that one yet. Okay. So here's the RESTFulSense version 2.0. Okay, so there's RESTFulSense, and then now I can just go into my controller. First of all, just installing this library with your existing standard, with your existing older version of the standard, if you're following that, it's not going to break anything. Technically, it shouldn't. Let's see, detected package. Oh, hold on. Let's see here. I have some upgrades that I have to make. Give me a second there. This is exceptions. All of this is good. Packages, full set reference package directly from project. Select a different version. Do I have this referenced in a project directly? I shouldn't have that. Let me clean up. I've been doing also some experimentation, so I hope there aren't leftovers. Restored. Here you go. Which project is this? This is the API test acceptance. Okay, because the acceptance. Okay, got it. Let's go up in here in the acceptance tests. Manage NuGet packages, and let's upgrade RESTFulSense as well. Here we go. All right, happy. Okay. Okay, let me try to build again. I'll take the camera here so you can see the whole action. Here we go. Building. All good. All succeeded. Okay, perfect. So we upgraded to this library. We just needed our acceptance test to actually, also have that running. And now let's go back to our controllers here. And in the student controller, instead of this old school thing that we used to do, extract the inner message and all that nonsense, you don't need to do that anymore. All what you really need to do is just take that guy and either pass the exception itself or pass the inner exception if that's what you care about. And you don't need that inner anymore. Gone. All cleaned up. Same thing here. Take that student validation exception, put the inner because that's where the message that you care about is living, and move on. The same thing with this guy. Instead of problem, put internal. This is really important. Put internal server error because that's the right name for this. I don't know really why the ASP.NET team decided to go with problem. I don't know if the name was reserved or whatever the case may be. But anyway, in this case here, I don't really need the inner message. I just have the message. See how my controller now is much cleaner. I'm not extracting inner messages or any of that junk. Now I'm just passing the exception directly, and this RESTFulSense library is going to pick up these validation issues and going to translate it for me automatically into problem detail. I'll show you that in a second. Okay, let's run our API again. Here we go. All right, building. The server is busy. Let's kick this off again. Sometimes IIS will do that. That's why sometimes people just kick off the standalone process, so they don't have to deal with that. Okay, hello Mario, the prince is another castle. Great, so I have an API running. Now check this out. If I go and hit this guy like this, watch the response. Look at my response here. It's beauty. It's work of beauty. How do I zoom out? Let me zoom out for you a little bit so you can see here. Look at this. Look at my response. My response now has the status code. It has the message on the exception. It has the specific error that is on that exception, particularly on that exception. And it also has detailed errors. Not just detailed errors, but errors that append. Like right now, you could tell me, Hassan, you have the ID, you have the property name, you have this, right? But watch this. I can go up in here and say created date. Watch this. Created date. Or sorry, created by. Like this. And I can add in a GUID in here. Like this. Just a random GUID. And I can hit this guy and watch what happens. Is it on this one? Let's do updated by. Updated by. Look what happened here. It says created by has two issues. So it will append the issues in your API. So now our response is much more standardized. Not just that, it has all the right errors in it. And whatever that error is, it will always point you to the right direction. If you look at the source code, that took me a little while. It took me a little while to fix that one for you, but now it's working. We have a better library and better engineering standard because of it. Let me show you here what this looks like from a code implementation standpoint. So you have all that stuff, but then if you go down a little bit, every single one that you're calling has the special URL that's pointing you to the right standard. I don't think you'll be able to find that anywhere. I couldn't find it myself. If you know an existing implementation, please point me to that direction. Otherwise, this is our guy right here. This is our library right here. Every single one, test-driven, you got it. Whatever you need. I'll show you how far this can go. Like with all the kind of errors in the world, now our exceptions are much more beautiful because you can just pass the exception to this library and it will take this and turn it into a truly meaningful exception. Now let's just do something really crazy here. Let's just go up in here and say, well, this is the message. I'm gonna go into my service here. And I'm gonna throw an exception for no reason, just a random exception. Throw a new exception like this. Right? So I'm basically breaking the entire flow. I'm surprised Visual Studio didn't dim. Yeah, there you go. Visual Studio say this is unreachable. This will never happen. Okay. So now I'm causing a service error, which is an internal server error. You know, I'm causing it intentionally. I'm faking an injury just to show you how beautiful this API is. Now, if you hit that API again, look, it'll say I have no errors specifically, but there has been a service error that occurred. Contact support for that. And it will give you the power to kind of go and add in help link if you want. Like your exception now has a help link where you can add stuff. But more importantly, here's again your section. Here's your data where you can go and open up that guy and it'll tell you exactly what an internal server error means. Exactly to that section. So whatever that exception that's coming from your service, it will take that exception and handle it properly for you and hand it over in a JSON object that your clients can consume and can work with. Okay. You have the right code, you have the right stuff. It's all good and dandy out there. No problem. Okay. So that takes care of the API. So we worked through the validation. We made our validations beautiful. Now we worked over to the controller, which puts us on the map in this area here. Okay, let's come to the client. Let's come to the serious stuff. What does that mean for our clients, the people that are going to be consuming our services? Because the HTTP response comes back. And remember, the whole reason why I built this RESTFulSense library is to be able to go and say, when an exception occurs, I want this to be a meaningful exception. Like if you look at the documentation of RESTFulSense, it'll tell you there very specifically, when an error occurs, I'm going to throw a proper exception. Look, there it is. See, if you get a forbidden, I'm going to throw HTTP response forbidden exception. So you can handle it properly on your client side if you're using C#. Now, let's go back to this guy in here, and let's see how the client is going to handle that. That's a completely another realm that you have to go through to be able to kind of work with this. All right. So do you guys remember we used to have a second there. We used to have how we demo our Blazor applications. How we demo our Blazor applications is that we go and say, hey, I want to be able to, you know, connect a UI to my API, right? Now, I want to be able to have my client, when we catch this HTTP bad request exception, that guy that comes from the outside world, I want it to also have this data in it. So we're going from an exception to a problem detail, and from a problem detail back into an HTTP exception for the client. So this pretty response that we have here, I want to be able to map that back into an exception for the client that will be consuming that API endpoint. How are we going to do that? Again, you really don't have to do anything on your client side. I already took care of that for you. All you really got to do is just upgrade your RESTFulSense library to 2.2.0. Update. Here we go. Okay, this is updated. Now I'm going to show you what that looks like. So my services at this point in time are doing their own little validation. I'm going to disable that for a second. I'm going to disable these client-side validations that I have in here. I'm going to disable all of them like this. Even the ones that try to kind of fill in information, I'm going to have it intentionally kind of, you know, put in an empty GUID or something like that here. Just to put in bad data in there. Okay. Okay. And then I'm going to put a breakpoint on the foundation level. So this is my foundation level in here. I'm expecting that if I enter bad data, I'm going to receive a bad request exception. I'm going to put a breakpoint right here. Ideally, if the exception happens in here on the controller, my library that I'm using to make that HTTP RESTful communication is supposed to kind of pull that problem detail and turn it into errors, something that I can consume back on the UI. So I can put each and every property on top of the box, the UI box that's targeting that. So it's all end-to-end. It looks like it's one application, but it's not. It's all going through the wire. Okay, let's do that. Let's run our, I think my API is running, so let's run our beautiful Blazor. If you're following my Blazor series, you'll notice that our UI now looks a lot better. We're using this Syncfusion library that's making things a lot better. So here's my Syncfusion library, and I'm not going to enter anything. I'm just going to go up in here and just click submit. And that's of course going to throw an exception on the API. And when it does, dependency, do I still have the, give me a second here. Do I still have that exception on the controller? Give me a second. Here is, no, I took that off. Oh, I don't have this running. It's a dependency, or it wasn't able to communicate with the API. You're not, of course, supposed to tell your clients, oh, the API is down. You just tell them, hey, a dependency error occurred, contact support, which is a good message in here. Okay, now I'm going to submit this, but the API is going to respond this time, and it's going to hit the breakpoint. Here's my breakpoint. So remember how I said the problem detail that's coming back needs to be converted back into an exception. And I want all the information that I can get about how invalid my data is. Now check this out. I'm going to do a quick watch in here. Here's my quick watch. And check the fireworks. Do you see that data piece? If you open up the result, lo and behold, you have all the errors. You have the key ID, key first name, key middle name, key last name, right? And then you have the values. Text cannot be null, empty, or white space over the wire. All right? So that basically means that on the client side, you really don't have to do anything. On the server side, if you're following the old version of the standard, please move forward and change your validation logic, because now you'll be able to handle validations a lot more fluently and a lot more beautifully than anything else. The real work really in this entire process is you going into your existing API and basically going and saying, I'm going to add these rules instead of these older rules. Now, what does that mean for unit testing? That means that your unit test is going to be much, much simpler, because instead of if you have 20 properties, and you have to write a new unit test for each and every one of them, you don't have to do that anymore. What you really have to do is that you need to go and say, here's all the errors that I expect to have, and here's all the errors that comes out of that exception. So you're basically testing the validation for the model with one test. Maybe you'll need a couple more just to explore, you know, edge cases where the created date is not the same as updated date, or the created date is at default value. That's it. Your tests will be a lot less, 100,000 times less. Okay. What's next, right? What's the next step? I'm going to update our engineering standard, the standard which is, you know, handles the documentation of all that work. So if you go into, not a lot of change that will happen in there, except it's just the little tiny piece around validation. So if you go into foundation services, if you go into validations in here, you'll see the piece around all down here is good, except starting from here, right? The implementation, see all that implementation in here? Even the, so this is structural, right? But there's also the dependency validation where you go and say, well, there's invalid student exception, all of that. Okay, we got all of this. And then there is duplicate key, which is things that are coming from the database. These have their own exceptions. Like everything else runs as usual. So null exceptions, you know, duplicate key, dependency exceptions, all of that kind of stuff will stay as is, no changes there. The only change that will really happen there in these structural and logical validations that happen in your system, you may as well collect all of those, you know, and throw it back at the client and say, hey, this model is invalid. Please fix all of these issues. Okay, so it'll be just very few, like dependency validation, all that. So just one section in our standard will change, but that section is really, really, really important that you understand, you know, how we changed our validation logic. There will be a lot of things that will change in our standard. You know, as I usually said, you know, there's so many different things I will be introducing slowly but surely. Because when we introduce something new in the standard, it changes around 20, 30 projects at a time, right? There's many, many projects out there. Some of it are already running in production. Some of it is already about to go into production. Some of it is out there as open source projects that people are learning from. And I want people to take this opportunity and learn from this experience and learn from how you kind of evolve an engineering standard into something that can be useful and can be standardized, something that people can actually rely on to build enterprise critical mission industrial applications. I hope this was useful for you. I hope this was something that you can take advantage of. If you have any questions, comments, or concerns, please feel free to drop a comment in the comment section. I really enjoy the discussions and the points that people point out. Sometimes I would forget something. Sometimes I would, you know, just go a little bit off into a different topic, and I forget to kind of wrap up an existing point. But also in the next video, you know, I'm going to show you, we're going to have to evolve our UI standard to kind of support that. So I'm going to show you how we're going to change our base components, text boxes, and stuff like that, where you can pass a parameter with bunch of validations to it. So that exception that happens, you know, I want to take that data and pass it to the UI so it can render the errors on each and every one of these text boxes in a way that you can test it and something that you can work with. So you can control where your validation is. It doesn't matter whether your validation happens all the way downstream in a 5th or 6th microservice downstream, or it happens exactly on the client side. It doesn't matter because you're collecting all these errors and you're displaying them exactly where they're supposed to be displayed. So there's a little bit of evolution that's going to happen on our engineering standard in terms of, for now, you can just print out all the values, right? And I'm going to show you that in my Blazor series. This upcoming video for my Blazor series is specifically going to be targeting, we're going to have to put the loading button on hold for a little bit, you know, and we're going to start talking about how do we map these validation errors right into the text box. So that's pretty much it. I thank you so much for watching. I'm sorry this is like an hour, almost an hour and a half video. Some people said to me, you know, try to get straight to the point and all that kind of stuff. But there's so much stuff that I just want to share with you, and I try to kind of, this is the short version of really what I'm trying to say to you. But hopefully I'll be able to kind of put a little bit more detail in a shorter time. As usual, if you have any questions, comments, or concerns, please feel free to drop a comment in the comment section. I appreciate you watching this video, and I'll see you in another one. Don't forget to like and subscribe. Thank you so much for watching.